Hi guys, welcome to another coding challenge. In this one we're creating some 2D mountain terrain, so you can use this in like a endless running type game as the background for it, or just for anything else I guess really that comes to mind. So yeah, let's get started. Alright, so I've got a blank processing sketch in front of me and we're going to try and make some scrolling mountain background sort of thing. So you could use this in a game or something like that. So firstly, I'm just going to set the size of the window. So that's pretty standard stuff. And so I think the way that we're going to do this is we're going to store an array list of points that will draw out the mountain landscape. So we'll need to create an array list for this, obviously. And it will hold a bunch of p vectors. So each vector will hold the position of each point, and so we'll draw a sort of zigzaggy line using that. And I think what we're going to try and do is have multiple of them that are all moving at different speeds so that it kind of gets that 3D effect. So if we call this mountain 1, and I think if we have maybe 3 of them would look pretty good. And so that equals an array list of p vectors like that, and then we can copy that. Oh, I forgot to write new. Alright, so what we want to do is we want to be able to populate all these arrays with points that are sort of like a mountain range. So it's going to be a zigzaggy line that's sort of randomized so that there's high peaks and low troughs and all sorts of stuff. So maybe if we try and make a function that you feed it the array list, and it will fill it up so we don't have to have 3 separate things for the 3 different mountain ranges. So we're going to call it void, I guess, generate. And so it'll take in an array list of p vectors, and we'll call it mountain. And then also what we're going to do is we're going to give it a y coordinate that the mountain range will sort of centralize on. So for the closest one it'll be lower down on the screen, and for the further away ones it'll be higher up. So what we'll do is we'll also give it then a float called y. Okay, so for actually generating the first one, what we want to do is we'll also need to give them a different size, because obviously the ones that are further away will look smaller than the ones close up, so we'll give it a float size as well. So what we want to do is we want to start at x equals 0, and then keep generating points until we're off the screen on the other side. So the best way to do that is with a while loop. So we'll say while mountain dot get mountain dot size -1. So that's the last vector in the array. So we get that. So while that dot x is less than width, we want to be generating points. So why is it giving me an error? Oh, I didn't spell it rightly. Spell it rightly correctly. Alright, so while the last point is still on the screen, we're going to keep adding points until eventually we're off the screen. So what we want to do is, I think we sort of want to generate 2 points at a time. So one for the bottom and one for the top. So if we do bottom and then top, and then bottom then top, bottom and top, until we're off the screen, we should get that zigzaggy sort of look to it. So, and so doing it like that, actually we could just generate it one at a time and make it randomly be above or below that y value that we've put in here. That might generate some more organic looking things. So if we say mountain dot add new p vector, and we want the x coordinate to be so we might need to generate 1 point first before we do this while loop, just because I want to reference the previous vector in the array list and get its x coordinate and build off that. And so if there's nothing there, it'll probably throw an error. So I'll put 1 point in first and then go from there. So we want to have a new p vector, and it's going to have an x of 0, and then we want to have its y be the y value that we give it plus random. I can't spell today. Random, and from negative size to size, like that. So that'll be the first point we generate, and it doesn't like that very much. I don't have enough brackets. Okay, so that'll be the first point, and then all the subsequent points will be generated pretty much the same, but instead of having 0 as the x, we'll say mountain dot get mountain dot size -1. So again, we're getting the last thing in the array. So we get that dot x plus size. So we'll be stepping over. Actually, we could make this random. So plus size and then plus random of minus size on 2. These are all, I'm just making this up, so we might need to tweak these values. So it'll be at least half size and could be up to 1.5 size as the x spread of these mountains. And then the y, I forgot a plus here. And then the y will be the same, so it's y plus random of plus or minus size. So, I've done it again. There we go. Alright, so that's a fairly long line. I don't know how many brackets I need. Yeah, okay, so what we're doing is we're looking at the previous point and getting its x coordinate, and then we're moving up by size, and then we could go up another half size or down a half size, somewhere in that random range, and then the y value will be on the y-axis that we give it, and it could go up size or down size. So we should see that we get a sort of jagged line created from here. So what we could do is now try and see what we've created. And so I'll write a function now that can show what's in these array lists onto the screen. So if I create void, I'll call it show, void show, and we'll give it an array list of the mountain, like that. And then we want to say for int I equals 0, I is less than mountain.size, I plus plus. So we're just going to go through all of the vectors in the array, and we're going to say, so what we want to do is we want to create a shape. So we'll go begin shape. So what this allows us to do is create vertices from the points, from the p vectors, and it'll actually create that into a solid object, so we can choose the color and outline of all of that. So we say begin shape, and then we'll want, so that the first point in this array is at x equals 0. So what we want to do to make sure the mountains, to stop some weird stuff happening, we want to have a vertice in each of the bottom corners, so that the shape's closed and we don't have a weird line floating around. So if you play around with this code, you can change this show function and sort of see what happens. But so I'm going to before we even get started, I'm going to add a vertex at the bottom right corner and the bottom left corner. So the bottom right is at width and height, and then the bottom left is at 0 and height. And then we're going to go through the array and say vertex at mountain.get i.x and mountain.get get i dot y. Getting all mixed up there. And then we need to close the shape at the end, or actually, no, sorry, end shape. But then we want to put in the brackets here close. So what that does is, instead of the shape being open to the end, it'll draw a line from the last point back to the first point again, so it'll create a full loop. So what that should do is go then to that width and height, the bottom right corner, it should draw a line back down to there. So now if we say generate, like that, mountain 1, and we'll just say width on 2 for the moment, and then the size can be 100. If we do that, and then we say show mountain, my typing today is atrocious, mountain 1, we should be able to, when we run this, see that we get, oh, here it is, so we get a sort of mountain range looking thing. So and if we run it again, you'll get a completely different result. There you go. So now what we can do, well, firstly, I guess we want to generate all 3 mountain ranges, like that. And we might want to say, we might want to store the y value for these mountains in its own thing. So we can say float m1y is width on 2, and then float m2y we can say is width on 4, and then float m3y can be width on 6 or something like that. Not too sure. We can tweak all these values, obviously, if they're not right. So that's m1y, this is m2y, and this is m3y. I guess I'll just I guess I should make variables for these as well. So float m1 size is going to be 100, float m2 size will be 50, and then float m3 size will be 25. So we'll copy those in now. Whoops. 2 and 3. And then we can show mountain 1 again and just see what that looks like with those values. So that looks not very good. What have I done? Alright, so I've tried to use this height value before I've set the size of the canvas, which means that it's at a default size, which I think is 100 by 100. So, okay, that's so annoying. Okay, so we'll keep all of this here, but I'm just going to declare them in the setup function. That's annoying. Alright. So like that, and like that. So if we run that, okay, that looks much better. And I changed that while I was debugging to that. So if we run that, it should be back to normal. Good. And then we should be generating all 3 sets of mountains. And then if we show them all, and actually we want to show them from the back to the front. So we want to start with the third one, then the second one, then the first one. So if we show them, you can see that it almost looks like sort of mountains, I guess. So now what we want to do is we want to start scrolling them across the screen and generating more points as they move off the screen. So we want to say, we want to create a move function, and it will take an array list of p vectors, and we'll call it mountain again, and we want to give it a speed. And I think that's all it will need. Okay, so what we want to do to move them is we want to say for int I equals 0, I is less than mountain.size I plus plus, and then we want to say, so we want to move the x point of each vector across by that speed variable. So we'll say mountain dot get I dot x plus equals speed, and then there are two things now that we want to check. We want to check how far across the first point is to see if it's past the edge of the screen, and we want to check the last point to make sure it's still off the screen, and if it's not off the screen we need to start generating some more points. So we want to say if mountain.get 0.x is less than, actually we want to check maybe the second point, because if, say we've got a line like this and it goes off the screen and we delete this point here, then that'll disappear and we'll have the point up here. So we want to check if the second point's off the screen before we start removing them, I think. I'm not sure if that makes sense to you, but if you want to fiddle around with this code, feel free, and you can sort of play around with these values and see what happens, but I think we'll need to do that. So if the second point x is less than 0, then we want to remove the first point, and so this will just stop the array getting too big and us drawing points on the screen that we don't need to anymore. So then we'll say mountain dot remove 0, and then we also want to have a while loop that is essentially the same as this one here. So that will mean that we'll have to feed it also here. We'll need the y and the size. So if we just copy this in, and we might want to add in a little buffer to the width so that it'll start generating points while it's still off the screen, because otherwise we'll run into the same issue that we would if we started removing points too early. If we start generating them too late, it'll be all glitchy on the screen. So if we just add in size, so that should be enough for 1 point, but what we could do is we could just say 2 times size just to be safe, and then we'll add more points onto the screen. So what we can do now is if we move this all the shows into the draw section, and then we also say move, so it's mountain 1, the speed for the first mountain, so the closest one should be moving the fastest, so if we say something like 5, and then the y is m1y and the size is m1 size, like that. So we want to do that, and then we'll copy this and do it for the other ones. And then once we've picked some colors, I think we'll be just about done. So just need to change these. So now if we run this, we should hopefully see that they're moving across the screen. Okay, so I've moved them the wrong way, firstly, and then also you can see that we're not actually clearing the screen. So we'll fix those up and we'll see how it goes then. So we'll say clear here, and instead of plus speed we go minus speed, And there you go, we've got some mountains moving across the screen. So I think they're probably moving a bit fast, so I might tone it back a bit. And so then, actually we'll change this to be background, and we'll try and get a bluish color. So RGB, so 0, like 50, and then 255. That's way too dark. Okay, so if we change these to 100, it should be a much lighter blue. And we probably want more green in there. Okay, that's a nice blue. I'm going to say no stroke up here, so we don't get the outline around the mountains. And then before each show function, we're going to say fill. So we want the closest ones to probably be like a green. And then the further back they get, I guess they should get more and more blue. Oh, that's the furthest away one, isn't it? So we want them to get more and more blue as they get further away. That kind of works, doesn't it? And they're not moving at the same speed. Okay, so I think we're done. We've created some side-scrolling 2D terrain. So you could use this in like a platforming game or something if you wanted to. You can, you can use this as the background as you're doing like an endless runner sort of thing. I don't know, it's up to you. But yeah, so there'll be a few links in the description below. So firstly, there'll be the link to the GitHub, which has got all the code from this exact example, so you can download it yourself and play around with it. There'll also be a link to processing, which is what I'm using to actually write this in, so there'll be a download for that. And then lastly, there's a link to my website where you can check out some projects I've done and also vote on topics for the new videos in the future. So yeah, thanks for watching. I hope you enjoyed it.